Tonight is November the 17th, 2019. I just want to show you, in case other people have never built and laid out chassis, this is the way I've always done it. Makes sense to me. Works pretty good, and I can change it. This is a plastic cover that's on the aluminum. You have to peel all of it off, but you can mark it up and then peel it all off, and so you don't have to mark up your chassis. Of course, if you do use a magic marker, it wipes right off with alcohol. But anyway, I also get a lot of questions about where do I get these chassis, and I buy them from Mouser. Here it is right here. Mouser. Show you this. Mouser Electronics. www.mouser.com right there. And here's the part number of that particular one. 546-1444-17134. You may not want this particular chassis, but it'll put you in the category of chassis, and then you can pick the size. This one is a 17. I always buy 17-inch chassis because they fit 19-inch racks. This one is 17 by 4 by, I'm not sure how deep that is. That's just a little bit less than 17. A 17 by 17 by 4-inch chassis. They're pretty pricey. They're like 65, 70 bucks. They're not free. But anyway, here's the way that I've always laid out my stuff. Just to get started. I probably should have my tubes in there, but I think everything's going to be all right. I may put them in there just to make sure that things aren't too tight. 866s, those are the big bottles, so that's the biggest tube that'll fit in that socket, because it's kind of easy. If you're not careful, you can get your tubes too close together to where possibly they don't even fit. But you know, the other newer models was actually a bit smaller. The VR tubes, which will be the regulators for the screens. Here's the this will be a Williamson driver for the four 1625s. The bias supply that just plugs in, power transformer and output transformer. Excuse me. So I just lay it out like this, the way I want it. I can move it around, and then I just start marking it. And then, of course, I will use a T-square and draw straight lines so everything is parallel and perpendicular. But that's it in a nutshell. The next time you see this, a few seconds from now, will probably be a week or two from now. I hope I have plenty of time to work on it. I enjoy it a lot, doing this kind of stuff, so we shall see. But I thought I would just make a comment of where I get the chassis, a part number to get you started, and my the way I start laying out things. And you know, this is probably pretty much how it will turn out. You have to, I mean, since it's not a fancy stereo amplifier, that it's going to have a gain control wherever I decide to put that, and a microphone input. That's about it. I'll probably put some kind of a time delay relay circuit in it. Either that, or maybe a push button or a spring-loaded high voltage switch, because you know, you want your MV rectifiers to be on for a minute or two. After they've been cooked in and they're thoroughly cooked in, you really only have to let them warm up for a couple of minutes. And I can say that from experience, because I use MV rectifiers every day in an amplifier I have down in the basement. I use on 20 meters. And I turn it on. I always give it 2 or 3 minutes to warm up, and then I've never had any problem with it. And I even do the unthinkable, and I use MV rectifiers into a capacitor input filter, because I use them in a voltage doubler. You can't have a voltage doubler without having the rectifiers work directly into a capacitor. And while that's not recommended, it works great. So there you go. I'm going to get started on this, but I want to show how I get started. And I'll see you in just a few seconds. I've got to show you one more little trick here that I've used. Now, obviously, you can use a T-square and measure properly. And one of the things I use, more than you might ever think about, is a micrometer. I use a micrometer all the time to measure tube sockets, especially because tube sockets are oftentimes like 1 1/8 inch. See, these are just 1 3/64, but it's got to be a little bit bigger than that. So it's a Actually, there's 1 1/8. That's actually a little bit, that's a little bit sloppy right there. So I'm not going to use this socket. But these sockets right here, see, well, that's 1 1/8. That's a little loose too, isn't it? And that's not the one I'm thinking about. Well, now, darn it, which ones am I thinking about? Oh yeah, these ceramic ones over here. So I'm going to go and tinker. I tinker with the details a lot. See, this is 1 1/8. See, that one, that's the one you want. That's the one you want in a 1 1/8 inch hole, and I happen to have a 1 1/8 inch green leaf punch. So these sockets I will be using. These I won't be using because they're just a little bit too small, but I'm just using them now to stage the thing. However, what I wanted to show you, because it has very little to do with that, but when you start laying out transformers like this, they can get to be a challenge, and you can measure it enough times that you can get the holes in the right place. But one way that I've learned that sort of cheats is use fingernail polish. I have just about every color fingernail polish ever made, and I use it to mark wires and whatever. I hope this turns out good. But here's one of the things I do, and it comes off pretty easy. It can also be used for a very mild form of Loctite too. It actually works pretty good and can be taken off. I put them on there like that. Kind of get the top back on before it dries, and I want the transformer to mount right. Here's the tedious part, especially when my arms hurt so darn much all the time, and I just set it down right there. Right there. And then when I lift it up, hopefully, voila, there you go. I got 4 spots where I need to drill the holes. I don't know if you can actually see those little dots on there. You probably can. They can show up in the camera a whole lot better than they show up in the viewfinder. But anyway, that's just one thing. You want to get all your sockets, like I say, is the same size if you can. And I've got a bucket full of them, and you know, they're all surplus stuff. Just about everything I have is military surplus, so there you go. Well, it's November the 18th right now, and this is the state of the Modulator amplifier. There's going to be a few more small holes that have to be drilled, but that's just the nature of building. I'll have to drill some small holes right here, run the plate leads down into. Same thing over here for the high voltage rectifiers. I wish now I had located these over here and these over here. Now, obviously I can change the sockets. Fortunately, the sockets are the same size, so they're completely relocatable from here to here and vice versa. But it puts these big guys up a little bit too close, in my opinion, to the power transformer. So I think I'm going to leave it like it is. The reason I would like to relocate them over here is just closer to the transformer, and actually the leads may even reach. I've provided a socket for this regulated power supply. Pretty little thing for the bias, but interestingly enough, this big guy right here has some taps on it that give me 80 volts and with a center tap. So I could put that into a bridge and get the bias supply right out of here. I'm going to get the screen supply from a dropping resistor stabilized by these voltage regulators. We're not going to be running these as triodes because we're not going to get the kind of power we want out of them as triodes. They're going to be run as beam power tubes. And at that, we have to provide the recommended screen voltage, which is quite a bit lower than the plate voltage. The plate voltage is going to be fairly high. The maximum recommended, I think, is 750 volts for these 1625s or 807s. And this thing right here is 1400 volts center tap. So into a capacitor input filter, a pi filter, it's probably going to give me about 20% more than 700, which will be about 140, which will give you about 840 volts. But that's okay. I don't mind running things pretty hot. they oftentimes perform much better. You know, if I've thought about this, and I thought I'd mention this in some of my videos. If somebody gave me a choice, let's suppose I was looking for 450 volts on the plates of a tube, and I had a transformer that would give me 40 volts less, and I had another transformer give me 40 volts more. So my 450 would either be 410 or 490. I will definitely take the 490. You will get so much better performance. You lower the plate voltage 40-50 volts, and things can change dramatically. And you raise it 40-50 volts, and things can change dramatically too. Now, I know that people are oftentimes concerned with the longevity of the tubes and what have you, but I tend to run them hot, and I get real good performance out of them. That's just the way I look at life. So there you go. That's this part. I painted it with a gray. This is actually primer, but it says it was self-etching primer, whatever that means. I actually don't know what that means. But anyway, this is what it is for the moment. So now I gotta continue. Okay, well, it's November the 19th, 2019. I've made a lot of progress on it. I've, for the most part, finished the power supply portion and the filaments. This is kind of where I stop and take a break and check it out and make sure that what I've done so far works. I don't complete the entire project and then plug it in, cross my fingers, and hope it works. I make checks along the way. What I have hooked up right now is, I'll show you underneath it the progress that I've made. Like I say, the filaments are all wired. I haven't done anything with the VR tubes here in the back. I haven't done anything with the bias here. And as I think I've mentioned in a little earlier, that I may not even use this. This thing is so special. It is just so special that I may use it somewhere else, because in such a unique condition, this has 80 volt center tap winding on the high voltage primary. That's just perfect for bias. I'm sure that's what it was used for. I don't know what this thing came out of or where it came from, but I did you know, take the end caps off and paint it, so that's why it looks so nice. But what I'm going to show you now is the filaments are all lit. You really probably can't see them unless I get the camera up there really close. Let me turn out the lights here. Maybe you can, sorta. Well, I think you can see that 6SN7. These guys are lit too. You might be able to see that one over there. Well, now we're in the dark. Okay, let's put some light on. The 866 rectifiers are lit. They're all warmed up. And what I've done is I'm going to put a relay in it to ground the center tap to turn the high voltage on, so I can let these things warm up as they're supposed to. So I just got through doing it, and I wanted to make sure the high voltage came up properly. And let's watch it here. It's on the 1200 volt scale, and when I ground the center tap with my left hand in my pocket, I only work with one hand. Let's see, hang on just a second. Okay, left hand in the pocket, right hand. Yeah, just work with one hand. You may have seen those things flash. Well, with no load at all, I've got let's see, that's 1140 volts. Let's see, no, not 1100, 1400. 1,400. That's right. Okay, that's with no load. Now, when I load it down, it's going to come down quite a bit. It's probably going to come down to 850, 900 volts. I don't have a load to put on it right now. I have like 1 megohm resistors across each of the capacitors to bleed, not actually to bleed it off, it does serve that purpose too, but to equalize the voltage. I'm going to disconnect the ground, and you'll see it, the voltage start to come down very slowly. Now that is not ideal, because you know, you have to wait several minutes for it to come down, because it's coming down slowly. But right there's still 800 volts on those capacitors, so that could still knock your butt off. So anyway, let's this thing calm down, and then we'll take a look underneath. I'll show you what I've done for those that are interested in, I guess, the stages of building. This is just the way I've always done it. Whether it's right or whether it's wrong, or whether it's the best practices or not, I don't know. And I'm always interested in hearing how you guys do it. Let's zoom back out here. And here in just a second or two, I'll flip it over and we'll look underneath it. Okay, everything is completely discharged and it's safe to work on again. It's no more dangerous than dropping a brick on your foot now. This is the way I like to build power supplies. I've got 3 100 microfarad capacitors in series on each side of the pi filter. This is a 500 milliamp 1.5 Henry choke. So I've got 33 and a third, thereabouts, you know, 33 microfarads on each side of a 1.5 Henry 500 milliamp choke, because they're 100 microfarad 450 in series, so it gives me 1350 volts. I like to have plenty of capacitor reserve voltage, so in case something soars out of sight, then it won't explode my capacitors. I mounted a phenolic type of a board on it. It's actually not phenolic, it's some sort of, I don't know what this stuff is. It's not fiberglass. And then I use goop. Oh yeah, goop. That's something that not everybody seems to know what is. Let me find it. Well, darn. It's called G-O-O-P, goop. I have used that stuff so many times, I just can't count it, and I can't find it right now. But what I do is I just put a little blob on the bottom of each capacitor and stick it to the whatever I want to mount it on, and you can pull it off. It's not easy, but you can pull it off, and it'll hold, I think, until eternity. Good stuff. Here it is. Here it is. Oh, there it is. You might want to use some of this kind of stuff. Now, I've been using this stuff. I've used a lot of it for years. I mean, you can use it to fix your plumbing. You can glue your shoes back together with it. You can mount capacitors with it. It's amazing stuff. It's best when it's very, very liquid and sticky. It can, sometimes it doesn't always come the same, and sometimes it gets a little dried out and kind of gummy, and then it's not quite as easy to work with. But anyway, you can see the output transformer over here, the 4 1625s. I've got the filaments wired parallel. I positioned them so that the filaments are facing each other, so that I can run the wire straight across. And over here in this corner, on this little board, is where I terminate all of the wires out of the transformer. So that's it. Got to keep moving. Got to work on it every night, every day and every night for 3, 4, 5 hours. It's a big project. But what's next, of course, will be completing these VR tubes for the screen supply, determining exactly what the resistor should be from the power supply to give proper current through the VR tubes, so as to put them in their proper working range, and then wire this Williams type driver up over to the finals. I mean, it's, oh, I don't know, I'm going to guess it's about 10 or 20 more hours of work. but I think it's looking nice. It's not terribly heavy, but it's not light either. I have wrenched my right shoulder lately, and I go to physical therapy, which is a good thing. So there you go. Keep moving. Stay safe.